first of all, I'd like to extend my gratitude to you for the short notice on Wednesday. We called out a cancellation of the class, but we did basically say, hey, this was a time to work on assignments or solutions you hadn't completed yet. On Monday, we had essentially taken up a review of the duality of routes and nearly completed that review of concepts. And the intention was to go ahead and finish. And then between Monday and Wednesday, I discovered that the previous season, there was a two-part explanation of the duality of routes that was quite a bit more comprehensive. And I also had experienced some networking issues. At the time, I was attempting to work the Zoom session on Monday, and so we had some recording issues. Rather than re-recording a portion of the other thing was, to make matters worse, I had, under the moment, forgotten to share the screen. And then some minutes into this, I don't know if you remember Monday, somebody said, hey, we're not seeing anything on the screen. And there were others that had posted a chat in the chat, hey, we're not seeing anything on the screen. So it was kind of like a circus of errors on Monday. But what we're going to do is reclaim everything. We're going to reclaim the gap in our progress and reclaim that ground. So between Monday and Tuesday, I found these two separate recordings from two successive sessions last season, where the explanation and then deeper dive was really quite thorough about the duality of routes. And so this is what I posted instead for our Monday session. You could consider it to be kind of like part one is Monday and part two would be Wednesday, the class that was canceled. So what am I saying? It is my expectation that if you were not present during the Monday session, you would want to look at the second part of this, because the first part would have been covered. But if you weren't present on Monday, you'd want to do both, right? And in terms of understanding how routes make the internet and internetworking possible, this is a linchpin. If you understand the essentials of content in these two sessions, or in most of it from our session on Monday, then you're in a better shape to finish the solution, right? So we did walk through a bit of the solution last Friday, just to explain what was expected and how that's supposed to work. I have been picking up from a couple of students that there was a gap in the detail. It had to do with the router in the solution. If you do not configure a second interface between the two routers, basically the pings don't work. And so this is something that may have been some detail in the recording that wasn't as intentional or as explicit. Oftentimes in a solution, I'll go ahead and demonstrate one thing that has to be done on the first router, and the understanding or expectation is, okay, you're going to do the same thing on this second router. And if those steps are not completed in the same manner on the second router, and what I need to do is go back and double track to see whether or not that was the case. But it seems like there's more than one student that faced a challenge in the assignment completing the solution for this module, and I think it has to do with that one gap. So as you look at the module 3, there's a diagram, I think. As you start looking at it and look at the helpful hints, and it starts breaking out the basic diagram in one of the YouTubes. Okay, that's not found. We'll have to find out where that broken link is. Let's Okay. Oh, great. Yeah, nothing but ads. So as you progress with the configuration on the second router, both of the routers have two interfaces actually. The one interface with the .1 on the local internal network here on the left and then also here on the right. That interface is what connects devices in this network to the outside world. So if there's network connectivity and data flowing to and from devices or systems on this network, you don't have to engage the router because the router is the gateway outside of the local network. But if there's a ping to another system on another network like this one over here, you have to have the interface on this side of the router configured, but then you also have to have the interface on this side of the router configured to connect with this side of the other router. So it's the .2 address that knows where this network lives. So when you're building the route, like we discussed on Monday, it's a simple command, right? You're creating a route for this network, and the point of access is the gateway address here. It would be a 10.10.9.2 in this case. On the other side of the router is a 172.16.9.1 interface that knows where these other routes live, right? So essentially you have a gateway here. Put another way, the router has more than one gateway, more than one interface. And it is the router to router interface that allows the connectivity between. If you don't have a ping, if you have a ping one way but not the other, then what that means is that the route is configured on one side but not on the other. If you can ping this way but not back, then it means that you have a route that's missing. I hope this clarification helps. But if you're still scratching your head as you're trying to complete the solution this week, don't hesitate. Some of you have already requested assistance, and we'll be ready to do that for you right after class and later today and on Saturday. So any questions about what I've just related for the solution? Okay. So what we're going to do is push back the deadline for the CIDR segmentation submission. I'll put the answer, I'll put the answer sheet in there, but I'd like everybody to submit this assignment before I do that. So if any of you have yet to submit, please get that in. And then before the weekend is out, I'll post the answer sheet. Remember that you'll receive credit if you submit the assignment and completed an attempt with each of the items, but it's up to you to use the answer sheet to check your answers. Any questions about that? Okay. So one thing I would like to share with you is a matter that we would likely take a deeper dive with in our last module, special topics. And it relates to virtual networking. And so virtual networking is a way to set up network infrastructure. Instead of using physical hardware, you're actually using virtual components. And so another way to explain virtual networking is a concept known as software-defined networking. And it's a little bit, it's a good bit more developed than that short explanation. But software-defined networking or virtual networking is a way of creating the network infrastructure, but doing it in a virtual context as part of virtual systems. How many of you have heard of virtual machines? If you had computer architecture last semester, I would expect everyone to unmute your microphone and say, "Oh yeah, I know what you, I remember that. Might be a good idea."
I remember.
Yeah, it might be a good idea
I
if
still have
everybody
the
had
app.
a chance. Let's just unmute the microphone and make sure everybody stays with us. Everybody take a
Yeah, I
turn
remember that.
unmuting and saying, "Yeah, I remember virtual machines from last season."
Yeah, I remember. I still
Okay,
have the app,
I
I
still
think.
have it.
Yeah, of course.
right. So here is what happened on Wednesday. And what I'm about to share is semi-privileged information. And I will not divulge the name of the organization. I'm going to change the names to protect the innocent, so to speak, right? I'll also illustrate what occurred on a separate system and not on the live system. But it has a lot to do with routing, and it has a lot to do with layer 3. And actually, there's some really cool stuff. And again, we will take this up in module 6 in our special topics session. All right, can everybody see my screen?
Yeah.
Okay, so what are you looking at? You're looking at a very powerful system that is capable of hosting between 16 and 24 virtual systems. So this is a virtual machine host or platform. And the actual system is sitting out in the cloud. So this is actually sitting in the mainland United States of America. You may have heard of VMware or Hyper-V, and in the Microsoft Server operating system, there is a server role known as a Hyper-V server, and it allows a system to host virtual machines. So if you had a system, that had 32 logical processors and 128 gigs of RAM, right? You could run several servers. And there are small to mid-sized organizations that are finding, instead of buying multiple physical servers, it's much more sensible to buy a large machine and then run many smaller machines. The simple truth is there are some network basics that are in the mix here. And all of us understand that each month Microsoft sends out updates, right? Everybody's seen this on their own laptop with Windows 10 or Windows 11, right?
Yeah.
Okay, so in a server environment, the same thing is true. And here's the fun part. When you set up a physical platform with a physical network interface, and then you install the Hyper-V role, what you're doing is saying, I want this machine, this server, to host virtual servers, virtual machines. And we are in the process of staging 4 of these same types of machines. This is the prototype. There are 4 new ones that are much more powerful, that have twice the capacity each. And 2 of those are going to be parked on St. Thomas for student use. 2 of them will be parked on St. Croix for student use, each of them capable of hosting up to 48 servers for a grand total of 192 virtual servers that we can allow students to connect to. Why is that a significant thing? Well, if we set up the integrated development environment, if we set up the office suite, if we set up all the resources that you need to engage your courses. The only thing you need for personal technology is a screen and some mouse or touch screen and a keyboard to interact with it. So you get a chance to do everything you need to do for your course on a system that's smooth, clean, and hot, and you're not subjected to the vagaries of personal technology use. Like, I don't know, it was slow this weekend and you went on some of those websites, and then your laptop started acting funny, or your tablet isn't the same, and it's really slow and messy right now. And when it comes to doing the assignments, like, I don't know, using packet tracer to build a virtual network, like, your machine doesn't work like it's supposed to. And those are the realities of, well, that's the reality of technology use when you're trying to get a job done. The simple truth is that a lot of workplace environments are struggling with this idea, because a lot of people who use technology want to have their own preference. They want to have a sense of ownership about what they use and how they use for their work. But the workplace doesn't want to pay a lot of money every so many years to buy a new laptop and a new workstation. And so there's a lot of back and forth, and a trend of late is to give employees an allowance, kind of like a uniform allowance or a wardrobe allowance or a professional development allowance. And they say, okay, so you use your own technology, but the data that you produce for our work here is ours, right? This is called bring your own device. That creates all sorts of challenges when it comes to networking. Remote access challenges, again, a special topic. Have I lost anybody at this point? Remote access. Pretend, let's all fast forward 5-10 years in the future. You're working for a company or an organization or a nonprofit or a government organization, or you've created your own business and you need to get a job done. Well, let's get back to the server, the platform. When I establish virtual machines in this context, what's created is a virtual extension of this physical network interface. And what is created and built on the fly is a switch, like a gateway or a router or all of the above, kind of a combination of all three. So it's an interface that's on the inside of this physical server, and it basically performs the function of a virtual gateway for all of the internal machines that are running. Here you see a listing of, let's see, 1, 2, 3, 4, 5, 6, 7, 8 machines. These eight machines are 8 servers. 2 of them are domain controllers. One of them is a DNS system. We have DHCP active in the environment and so on, right? And if you look at each of the servers, like, let's take this as an example, Polaris, right? Everybody with me?
Yeah.
All right, so when I look at the settings, Polaris has a network adapter, a virtual network adapter, just like it has a virtual hard drive. And the virtual network adapter is connected to a virtual switch called VLAN, right? So if I look at this, VLAN. Now let's go back to here. Oh, everybody see this? VLAN, right? Now, as luck would have it, sometimes when you have updates, you get more than you bargained for. Put another way, Microsoft has a habit of pushing critical updates and enforcing them on systems, whether you agree to click and say, oh yeah, go ahead, load the update, or not. When it's security critical, when it means that your system data can be compromised by nefarious or malicious people, or the data can be corrupted, Microsoft doesn't wait. They push out a critical update, and the critical update posts. What you're going to find when you take up CSE 410, Principles of Operating Systems, is that device drivers, hardware drivers in particular, are privileged components of system internals, operating system internals. What am I saying? That the hardware drivers that are created to make the physical network work, they have to be signed. They have to be crafted and coded in a very careful manner using safe coding practices. And one of the things that hackers love to do is to put a fake update out there and then capture your traffic because you loaded what you thought was an update. So Microsoft digitally signs, encrypts the signature for that driver so that it will load properly. Now, for all of this to work, okay, for all of this to work, we have to have a fixed IP address or a static IP address assigned to the network card. What am I saying? When I go into here and I look at the properties and I look at what's on here, I don't get an automatic IP address. Servers are supposed to have a fixed or static, unchanging. It's not dynamically assigned using dynamic host control protocol or DHCP. It's not dynamic. It's not random from a pool of addresses. It is intentionally set to a fixed value. It is manually entered. A fixed or static address is the cornerstone of server functionality. And if that address changes, everybody that uses the resources on the server gets screwed. If we rebooted all the servers you use on the internet and they picked up a different address, you would never be able to browse the web, work email, do network and social apps, none of that. None of that would be possible because the addresses would keep changing. And your ability to browse, to go to Google or Amazon by name would be compromised. The whole point of domain naming services and the domain name system is so that you have a solid anchor where you can reference a name, and the other stuff is changed or updated automatically in the background. And that's a special topic. We're going to cover some really cool stuff about DNS later in the course in Module 6. We're going to show you how to hack the internet, your local network, everything, with some very basic resources, including DNS. Well, where am I going with this? DNS pins the network address to a given interface. Now, what happens if Microsoft pushes out? Now, when you set up a virtual server, it copies or clones the network identity and the IP address from the physical address, and it transports them over to the virtual, and it creates this like virtual router, virtual switch. And it's this thing that all of the systems connect to. Now, on Wednesday, it turns out that an update posted a change to the network driver for the physical interface on a single machine that hosted all of the servers upon which the 5th largest employer in the US Virgin Islands depended upon. Let me repeat that. A network driver update posted to the physical network card on the hardware, the host, for a system that runs like half a dozen servers that the 5th largest employer in the US Virgin Islands uses to do business. Everything came to a screeching halt. And that's because, in layman's terms, what was not configured is what we call fault tolerance. You receive a physical address, well, you receive a network address from DHCP, right? Everybody knows this, yeah? Generically, you know that dynamic address, IP addresses are assigned to connected devices with your Wi-Fi router or in local networks. We all understand this at this point, yes?
Yes.
Okay, pretty much. With servers, there's a physical address that's not supposed to, there's a manually assigned address or a static address that isn't supposed to change. One thing that's really important to understand is that as a failsafe, one thing you can do is assign a static IP address to the network gateway interface, whatever, so it doesn't change. But then with the understanding that updates are a reality of our world, you know, there are critical updates that have to happen. And if there's a compromise, who wants the Russians or the Chinese or the North Koreans or our country's adversaries, or just plain hackers from organized crime emptying your bank accounts? Nobody wants that, right? So if Microsoft discovers something that has to be updated, they're going to push it. And when they do, this thing, when it loads with the update, it's going to be like it's going to reset to default settings. The default settings for this interface are what? Automatic. Now that means that all of the routes and translations between this interface and these systems all go crunch. They all explode, basically, because there was a static, unchanging IP network address that translated the network traffic between all of the virtual machines and the virtual servers and the actual physical real server, right? It all goes crunch. So what do you do to fix that? That's actually a pretty slick way to do this in your DHCP server. And this is, again, a topic we're going to cover in greater depth in our last module when we get into all the juicy hacking stuff. You take the MAC address for this interface. And how do you get that? Here is the MAC address for this interface. Everybody see this? We take the MAC address and we set up what's called a DHCP reservation for the same IP address. And the reason we do that is we tell DHCP, hey, if this happens to show up and it's asking for a dynamic address, I want you to give it this address. Now you're saying, wait a minute, that's statically assigned. Yep, it is for now. But if it defaults to dynamic assignment and it just picks any random address other than the one it's supposed to be on, you don't get network resources to save your soul, and nobody can do anything. They can't log on. They can't access their home folder. They can't get into their email. They can't do squat. And what you want to do is tell DHCP, when this special MAC address appears, if it ever does, I want you to automatically assign what I would otherwise manually assign. Do you understand what I'm saying here? You tell it, hey, if we have to use the spare tire, make sure it's the same spare tire on the same size, same dimensions, same air pressure, same everything, including the same wear and it's identical, right? So what happens is that the machine that's been updated throws a lung, rolls over and starts to die, and then DHCP says, what are you doing? Oh, I need an automatic address. It gets the same address it had before. It's just dynamically assigned temporarily because of DHCP reservations. At that point, the server comes up, the interface comes up, all the routing and all the translation that happens between the virtual switches and the virtual servers in the background. Everything blinks green and turns smooth, fast, and hot, and nobody knows any different. Okay. So I want to thank you for your patience on Wednesday. There was a ox in the ditch moment where we were called. I don't know if you know this, but UVI faculty is committed to community service. Has anyone heard that before?
No, actually.
You hadn't heard that. Okay. One of our missions for the university is to perform and to cultivate service to the community we serve, the U.S. Virgin Islands, St. Croix, St. Thomas. We're supposed to provide our expertise. One of the ways that I do this, and I claim credit for community service so that I continue to be a faculty member in good standing, is to use my subject matter expertise as a Microsoft certified systems engineer, somebody who's certified in building networks, right? To support organizations. And in this case, it was a very important organization. Not only was it the 5th largest employer in the US Virgin Islands, but it was also a nonprofit organization that provided hundreds of residents and citizens of the Virgin Islands on both islands with essential services. We're talking about charitable services, nonprofit kinds of stuff, housing, healthcare, you name it, the whole 9 yards, childcare, right? A very large nonprofit. And if hundreds of people on both islands are affected, I gotta throw my hat in the ring and try to help. And we went in there and we figured out what had happened. And it comes down to the routing that we're talking about right now in module 3, right? It comes down to the routing and translation, the very thing we're talking about right here. And the truth is, this is a cutting edge scenario. The fact that we would have a virtual system that hosts many virtual servers that operate in a very cost-effective manner for local organizations. This is the trend of the future: virtual systems, virtual networks. But it works just the same as physical networks. Okay. So, does anyone have any questions or comments or observations to share based on the material I just presented? We helped fix and resolve the disruption to the private network in a private cloud, in a manner of speaking, where virtual systems were used so that this organization, this nonprofit organization, could do its job, right? Okay, so the last topic we want to encounter in our module before we post the first version for your first attempt of the module 3 assessment is IPv6. We want to discover and relate the essentials about IPv6. Now, again, this is a special topic we will revisit for a deeper dive in module 6, the last module that we engage for this course. But for now, I want you to understand some basics about IPv6. And for this class, it's really important to understand we had a serious shortage. There were 3 adaptations the industry has applied to keep the shortage of public network internet addresses, to keep that from crippling our ability to operate on the internet and on our networks. CIDR is one of them. Reducing the size of networks to conserve the use of public network addresses is huge. So learning how to apply classless internet domain routing to subnet is a serious skill. And it's what we're doing right now to conserve scarce public IP address numbers that we have to have in order to be able to connect to the global internet. We can't do it without those, right? It is a critical dependency. The other thing we do is NAT. We've talked about NAT, network address translation. The last adaptation is IPv6, okay? So what I'd like to do is queue up the material about IPv6 and make quick work of it. But I also want to stress that in our references folder, not the resource folder, but the references folder. You all know about the part 1 and part 2 videos in the resource folder. In the references folder, there is a special topics folder. I expect each of you to spend the time to review the content of each of these links, okay? Because it's related and it enhances and supplements and extends the concepts in the study guide. So when we talk about NAT, we talk about how to do better, how you achieve better security with using NAT. And there's something about SuperNets, IPv4 and IPv6. These are related details, right? This one in particular, now that we're talking about IPv6, there are two in particular. This one and this one are really important. This one is provided as a courtesy of Cisco and the Network Academy, the same people that provide packet tracer software. I want to take a quick walkthrough of this, and I want you to be aware of the content in here. There are 27 slides, but only a couple of them are the most important ones, okay? So here it explains, we only have 128 bits of address space for the world. We ran out. It provides a lot of granular information about what happens if you increase the number of bits you can use for addresses. Put another way, when we went from IPv4 version 4 to IP version 6, we quadrupled the number of bits, but that does not mean we quadrupled the number of addresses. When we quadrupled the number of bits, every time you increase the bit, you square it, you quadruple it. It's by 8-fold increase, 16-fold increase, 32-fold increase. By the time you take that out, an additional 96 bits, 2 to the 96, you have so many network addresses. Each square meter of planet Earth has over 1 million network addresses possible. In theory, we should never, ever run out of network addresses ever again. Another thing that's different about version 6 is that we don't work with subnets. We don't use subnet masks. We still use subnets. We don't, and we still do subnetting. What we don't use is a subnet mask. We don't use a subnet mask anymore because half of this 128-bit range is designated for network identification, and the other 64 bits is identified or allocated for client. Put another way, and I want you to understand this in plain terms. Is everybody with me here? Can you still see this?
Yeah.
Yeah.
Okay, so I'm going to put 2 to the 64th. With version 6 of the IP networking address scheme, it is possible to have, let's see, million, billion, trillion, quadrillion, quintillion, 18 quintillion, 446 quadrillion. I hope I'm saying this right. Everybody follow what I'm saying here? This is million, billion, trillion. What comes after that? Quadrillion, quintillion. I'm pretty sure that's how it is. I hope I hope I'm not excoriated by the math professors after this. That's the number of networks you can have with the IP version 6 address range. That's also the number of hosts that you can have in each of those networks. Let me say that again. You can have 18 quintillion, 446 quadrillion, 744 trillion, 73 billion, 709 million connected hosts in each of the 18 quintillion, 446 quadrillion, right? Okay. So are we going to have resources for addresses anymore? Now, the same principle of having a network identity, which is like the zip code in your neighborhood, that's still valid. oh, we're gonna have an address that still identifies uniquely each of the connected hosts on that network so that you know which of the houses are different in that neighborhood. There's a unique street address for every connected host. That still holds true. So there are a lot of things that still work the same. But one funky little difference, and this is kind of irritating, is that instead of using ones and zeros or dotted decimal notation, they use hex. So that's an aspect of version 6 IP networking that gets to be a little daunting. And that is why we're going to spend special attention to it and revisit it later. We want you to know some things about how this works. Each of the 4 ones and zeros or bits represents a nibble, and 2 nibbles makes a byte. So 2 hex values represents 8 bits. Put another way, the hexadecimal number system, we've covered a little bit. We've just kind of glanced at it. I want you to understand the differences between, and then the decimal value, and then also the binary equivalent of the hex. Now, this is something we did cover previously, yeah? We showed you all 3 side by side, something like that, yeah? Early on, everybody remember?
Yeah.
Okay. What do you need to know in terms of the study guide? What's the most important stuff you need to know? Well, that's actually pretty straightforward, okay? If you look at section G, or student learning objective G, in the study guide, it basically summarizes much of the material provided by Cisco. Okay, so what am I saying? Start with this information first, okay? And I want you to read it at your leisure and try to digest what it's saying for each statement. So IPv6 uses 2 hex values for every 8 bits, 32 hex characters in all for a fully delineated IP. That means for a complete IP version 6 address, 128 bits. If you take 8 times 32, that equals 128 bits. This is the part that's scary, and this is the main thing to keep the main thing. Version 6 can run on top of current network infrastructure. So you can start turning on in your properties IPv6. And when you do, the protocols for IPv6 start running, and they run on top of the existing IPv4 network, but it can open up some serious vulnerabilities. Put another way, I want you to understand this with absolute flawless clarity, everyone all together, before we clear today, this week, the rest of the semester. If you have a chance to use IPv6, that means you do it locally, you do it with the internet and all of your equipment. You either do it full tilt, 100%, or not at all. If you do a mixed bag and you do something goofy like this, where you let the default value for your network stay in place. What am I talking about? On this here, every single one of you should have IPv6 unchecked. Every single one of you should disable IPv6. You shouldn't walk, you should run home to your local business, to anyone who matters in your life. And you should check every device, every connected mobile device, laptop, computer, server, router, Wi-Fi access point. You should make sure that every setting that turns on IPv6 is disabled, because there are no internet service providers in the US Virgin Islands that are currently operating IPv6 properly. Which means if this default is enabled, those two protocols straddle each other and create a tunnel, and the hackers can saw right through it. I want you to understand this in absolute terms. Now, we've gone a little over our class, the end of class time, right? So it's 11:56. I don't want to read to you from the study guide, but I wanted to make sure everybody understood. At the top of this, right here, your goal today is to check your stuff. Pull up your screens and review the settings on your junk. For your sake, your family's sake, your friends, your neighbors, stop what you're doing, take the time, go in there, disable IPv6, okay? Now, all the rest of this is basic academic information. So it talks about, it compares how version 4 uses 4 octets for 32 bits, but version 6 uses 8 sets of hex values. This is what you're going to see for assessment items in the Module 3 assessment. I'm going to ask you the same basic, I'm going to ask you for the same basic information. How does version 6 differ from version 4? Oh, it uses hex values instead of binary or dotted decimal, right? Well, what else? This thing, when you have lots of zeros, you don't have to list all those zeros between the network address and the host address. You just put 2 colons. When you make a double colon like that, it's shorthand for, hey, I got all these zeros and I don't need to pay attention to any of these other values in between, which makes managing a network identity and a client identity a hell of a lot easier. If you understand the shorthands, you begin to understand a whole lot easier what the hell is version 6 and how do you make sense of it. It's actually a quicker, easier way to figure out and get your bearings. Am I on a local network? Am I on a public network? And what's the address of my local client? We are not going to require you to implement an IPv6 network in this class, but we want you to become familiar with the most important things, which primarily today is you don't enable it until your internet service provider says they're the only, that's the only way they're working on the internet now. And that's quite a ways off. You don't want others taking advantage of a new protocol to saw their way into your home network environment to steal your bank accounts. And I can't be any plainer about the risk there. A lot of people in this world really don't get that. And I hope that you get that today, here and now. I didn't want to start our first day of class like this because I didn't want all of you running, screaming from the room. There are other things when you're pinging for troubleshooting and you ping the loopback the address, that's the home address. It's called loopback. The version 6 equivalent of loopback is ::1, which is just another way of saying this in version 6. So there's some really cool, very basic. Oh, and there are no classes. We don't have class A, class B, class C. They don't exist in version 6. Okay? So I want you to read this. We'll take some time to look at it, the rest of it on Monday for part of our class, and then we'll turn you loose to finish your prep and to engage your first attempt of the Module 3 assessment. But you should, between now and then, disable your IPv6 options in every connected device in your home. If you have family or friends with businesses, don't waste any time. Tell them, hey, I think there's something we ought to change to make sure your network is safer. And seriously, everybody should do that this weekend. Not because it's assigned as an activity, not because you earn points in your class, but because you don't want to graduate from the University of the Virgin Islands having had this class and you're a sitting duck, or your friends and family are sitting ducks on the newest network that some internet service provider hooks up in your local neighborhood because the defaults are turned on. And you don't really get how exposed that is, okay? So this is no joke. And then take the time to go through these bullet points. Read each one at a time And what we'll do Monday, first thing, is call out the things that do not make sense, okay?
Okay.
Right? Everybody got it? Okay, we're gonna stop at this point and post the recording. So those who had to clear the screen will catch that last piece there. Any questions, comments, observations based on the material we have presented today? So the main differences, the most important ones are at the beginning of this list. As you go further down the list, those are nice to know. Most of these should be easy to read, right? So, okay.